Good afternoon, class. We are looking at Chapter 5, Polynomial and Rational Functions, Section 5.1, Quadratic Functions. We're going to cover quadratic functions, power functions, and polynomial functions, graphs of polynomial functions, dividing polynomials, views of polynomial functions, rational functions, inverses, and radical functions. And in this section, the objectives are recognize characteristics of parabolas, understand how the graph of a parabola is related to its quadratic function, determine a quadratic function's minimum or maximum value, solve problems involving a quadratic function's minimum or maximum value. All right, so what have we looked at? Reminding everybody of average rate of change, which in short is the rates of change of y with respect to x given 2 points. Lines in standard form are ax plus by equals c. Slope-intercept form would be y equals mx plus b. And point slope form would be y minus y1 equals m times x minus x sub 1. A linear function f of x equals mx plus b is considered increasing when m is positive, decreasing when m is negative, constant when m is 0. Average rate of change, also known as the difference quotient, delta y over delta x, or f of x up 2 minus f of x sub 1 over x up 2 minus x sub 1, is called the average rate of change of y or f of x with respect to x over the interval of x sub 1 to x sub 2, and can be interpreted as the slope of a secant line PQ. So if you have a curve, you pick up 2 points, P and Q, you connect them. You can calculate this slope, the slope of this line, in various formats. For example, if we look at these two pairs, x up 2, f of x up 2, x sub 1, f of x sub 1, delta y over delta x, rise over run, can be calculated using this formula, which is, of course, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. If you call this a comma f of a, this one b comma of f of b becomes this formula. If you stick with x and f of x and a f of a, you can use this formula. And if this distance is h, and this is a plus h, this point has coordinates a plus h and f of a plus h, you end up with f of a plus h minus f of a in the numerator. A plus h minus a results in h. So these are various formats of dealing with the average rate of change of y with respect to x, also known as the DQ difference quotient. Now, 5.1, quadratic functions. A quadratic function is a function that can be written in the form of f of x equals ax squared plus bx plus c. For real numbers a, b, and c, with a not being 0. A quadratic function occurs in applications such as motion of a projectile, etc. So f of x is 3x squared minus 5x plus 1. These are examples of that. G of x equals minus 6x squared plus 1. H of x equals half of x squared plus 2/3 x. And for example, a path of cannonball follows a parabolic shape. Graph quadratic functions by transformation. As you may recall, a basic parabola opens up when a is positive. This is when it opens up. This is the location of a minimum known as the vertex. When it opens down, A is negative. This is the highest point, location of the vertex, or the max in this case. And this is the axis of symmetry. You can fold it in half there, in essence. So what happens when you compare ax squared to x squared? If A is positive compared to f of x equals x squared, 3x squared has a larger y coordinate. Therefore, it gets closer to the y-axis. It rises faster than x squared. Whereas 1/2 x squared, it becomes sluggish and it gets closer to the x-axis because the y coordinate is smaller. If A is negative, basically it flips over with respect to the x-axis, looking like this. So this is f of x equals minus x squared, the blue one. If it's minus 3x squared, it's again getting closer to the y-axis. If it's minus 1/2 x squared, it's closer to the x-axis. But like I said, it flips over with respect to the x-axis as far as the transformation is concerned. The graph of every quadratic function is a parabola looking like this too. The vertex is the lowest point on a parabola that opens upward, or the highest point on a parabola that opens downward. So opening upward, A is positive, downward, A is negative. That's the vertex. When it opens up and it opens down, this is the vertex. And the coordinates, minus b over 2a is the x coordinate. And then if you plug in that value into the function, whatever this number becomes, evaluate the function at that, becomes the y coordinate. If you work it out, becomes 4ac minus b squared over 4a. You don't have to memorize that. Just remember x equals minus b over 2a. Y you plug in and you evaluate it. Quadratic functions, f of x equals ax squared plus bx plus c. Graphs of quadratic equations have symmetry about a line through the vertex. This is the axis of symmetry. This line is called the axis of symmetry with the equation of x equals minus b over 2a, the x coordinate of the vertex. In other words, when you try to find the vertex, you find not only x equals minus b over 2a as the x coordinate of the vertex, this equation is the vertical asymptote. So axis of symmetry, a line that divides a graph into two symmetrical halves. A is positive, the parabola opens up. Negative, A is negative, the parabola opens down. X-intercepts, as always, any x-intercept set y equal to 0 and solve. Y-intercept set x equals 0 and solve. And if you set x equal to 0, you get c, therefore 0c, the constant becomes your y-intercept. The domain is always all real numbers from negative to positive infinity. The range changes. Whether it opens up or down, the domain doesn't change, but the range depends on whether the graph opens up or down and the location of a vertex. If it opens up from the y coordinate of the vertex to infinity, if it opens down from negative infinity to the y coordinate of the vertex, that's why it changes. You have to figure it out. F of x equals a times x minus h quantity squared plus k is a parabola in vertex format. Some text they may call this standard, but in order not to mix them up, I'm going to call this a vertex format. The vertex has coordinates h and k, if you write it in this format. The axis for short, axis of symmetry, has the equation x equals h. Either way, whether A is positive and it opens up, or negative and it opens down. The parabola opens up if A is positive and down if A is negative. The larger the absolute value of A, the narrower the graph. In other words, if you look at this concept of a basic parabola y equals x squared versus y equals, let's say, 5x squared, it gets closer to the y-axis. That's the meaning of narrower. Normally, f of x equals ax squared plus bx plus c is considered as a standard form of a parabola. So f of x equals ax squared plus bx plus c. As I mentioned, if you are interested in finding the x coordinate of the vertex, which in this format you have it, one easy way is to just write x equals minus b over 2a. If you were to work on this by putting these two together, ax squared and bx, you can factor the a out. So this is the vertex we know. Or, as I mentioned before, you can say 4ac minus b squared over 4a. I want to quickly show you, if you put these two together, take the a out, you get a times x squared plus b over a times x plus c, and you are going to complete this square. I hope you remember. This is the coefficient of x divided by 2 becomes b over 2a. Square that, you get b squared over 4a squared, and you add it to both sides. And bear in mind, when you add b squared over 4a squared inside the parentheses, in essence, you are adding a times that. So therefore, a times that must be subtracted from it. So this part is a times x plus b over 2a squared. You're completing this square. These two, if you take a common denominator of 4a, because I can drop this a with the exponent, then I have to multiply this one by 4a. This becomes 4ac minus b squared. So that's why we have this expression. I just wanted to show you how to find that. You don't need to go that route. You can just plug in and evaluate it. All right, example one, we're going to go with the translation or transformation of a parabolas. Graph the function f of x equals 2x squared plus 8x plus 5. Find the vertex and the axis of symmetry. And so one way to do that, we are going to write these two together. And so we need to find the vertex. And to find the vertex, x equals minus b over 2a and plug in. Or if we want to go by completing this square, we take the 2 out, you get x squared and 4x. Now here's your b. Let me just write it here, and then I'm going to erase it. So b equals 4 divided by 2 is 2. And when you square it, you get 4. So we are going to add 4 here. which means I am adding 2 times 4. So to undo it, I can add 2 times 4 to both sides, or I'm going to add 2 times 4 and I'm going to subtract 2 times 4. So please understand, when I add 4 here, that means I'm adding 2 times 4. So if I want to use the same side, 2 times 4 minus 2 times 4. That's how you do it. The reason we do it on the same side because we want f of x to be in the format we want. Now this is 2 times x plus 2 quantity squared. This is 8, 5 minus 8. 5 minus 8 gives you negative 3. And we end up with 2 times x plus 2 quantity squared minus 3. Now to use the transformation. We are going to go with the vertex, and notice that the vertex is located at minus 2, minus 3. And if you wanted to go this route, class, let me just quickly show you. If you just wanted to say, okay, x equals minus b over 2a, that means minus b was 8, remember that? And then a is 2 times 2. And I hope you see that's negative 2, which is the same. So you could have done it that way as far as finding the x coordinate. For the y coordinate, if you plug in negative 2, it works it out and it gives you negative 3. I'm going to erase this part because I need the space. So we start with y. We start with y equals x squared. So again, or x equals minus b over 2a or negative 2, as I mentioned. Our next step is to multiply by 2, or you can move it to the left, either way. So if I multiply it by 2, there is a vertical stretch. Therefore, 0, 0 doesn't change. 1, 1 becomes 1, 2. Negative 1, 1 becomes negative 1, 2. So we took care of the 2. Now x plus 2 means shifted to the left by 2 units. So replace the x by x plus 2. That means shifted to the left by 2 units. If you shift this to the left by 2 units, what happens? The y coordinates remain the same. So this remains the same, but this one becomes minus 3. This one becomes minus 2. This one becomes 1 minus 2, which is negative 1. So look at what happens to those 3 points. Finally, we apply this negative 3. So we subtract 3. That means we shifted down by 3 units. So bring this one down by 3 units. Now, when you bring it down, the x coordinates do not change. The y coordinates, we have to subtract 3. So this 2 minus 3 becomes negative 1. Same thing here. And this one becomes negative 3. So notice how the transformation works. So if we were to transform it accordingly. Here's the next example. Locate the vertex and axis of symmetry of the parabola f of x is equal to negative 3x squared plus 6x plus 1. Does it open up or down? So to find the vertex, we're going to go with the easy way out, and we're going to use x equals minus b over 2a. Again, b is 6, so minus b is 6, and then 2 times a. So this is a, this is b, this is c. So just plug in. Obviously, the top and the bottom are both negative 6. The answer is 1. And now, in order to find the y coordinate of the vertex, plug in 1 into the original function. So this is 1 times negative 3 is -3 plus 6 is +3 plus 1 makes it 4. The vertex is located at 1, 4. Axis of symmetry, we've already worked it out. X equals 1. A is -3, so it opens down. Very straightforward, everybody. So as it was mentioned, f of x is ax squared plus bx plus c, and the vertex is located at minus b over 2a and f of minus b over 2a. B squared minus 4ac, as you recall, it's the discriminant for quadratic formula, and it plays a huge part. What happens when it's positive? You have two distinct x-intercepts because there are two solutions, right? Two real solutions. So either looking like that, or looking like that. So we have 1 and 2. We have 1 and 2 intercepts. Whether it opens up or down makes no difference. It remains the same. What if b squared minus 4ac is 0? Then we have a 1 x-intercept. It's a double root, as you recall, with the quadratic equations. So actually, let me just remind you in case. The quadratic formula x equals minus b plus minus the square root of b squared minus 4ac over 2a, and b squared minus 4ac gives us a lot of information. So in this case, there is one solution here, if it opens down here. And finally, if b squared minus 4ac is negative, then there is no roots, no real solutions. Therefore, there is no x-intercept. So in the case that b squared minus 4ac is negative, there are two complex solutions, imaginary solutions, and therefore there is no x-intercept because x-intercepts correspond to real solutions. Write f of x equals x squared minus 6x plus 8 in the form of f of x equals a times x minus h quantity squared plus k, which I call the vertex format. And then determine whether the graph opens up or down. Find the vertex, axis of symmetry, draw the graph. Find intervals of increasing, decreasing, domain, range, and all of the above. Okay, let's discuss all of it. So first and foremost, because of the format they want, we are going to complete the square by two different. You've seen the previous method. We put these two together and we worked on it. We can move the 8 if you want, and then bring it back. This is another way. I want you to pay attention to this method. It may work better for some students. So I'm going to move the 8, and I'm going to work on this. And this piece, you want to make sure a is 1. So if it's not, you have to divide by it. If you go this route, okay, this is doable because you don't have to divide by anything. So we are going to add b over 2 squared. So I'm going to write b is -6 divided by 2 is -3. Squared is +9. So let's add 9 to both sides. And on the right side, as it's been mentioned before, you basically get x and b over 2, which is -3, quantity squared. On the left side, -8 and 9, they add up to +1. And so now I'm going to move the 1 to the right. And it is in the format we want. And I hope you recognize that the vertex is located at 3 comma -1. So vertex is at 3 comma -1, the axis of symmetry x equals 3, and of course a is 1, it opens up. So this information should be very straightforward. Here's the table giving us the information, reminding everybody. The y-intercept, all you have to do, look at this one, is the constant 0, 8. The x-intercepts, we will work them out. X squared minus 6x plus 8. You set it equal to 0, you get 2, 0, and 4, 0. I'm going to quickly show you. And we have the vertex at 3, -1, and this is an extra point. Let's look at the x-intercepts. If you set this one equal to 0, x squared minus 6, 8 plus 8 equals 0 means x minus 4 minus 2 equals 0, because you want two numbers. The product is positive 8, the sum is -2. This gives you x equals 4, this gives you x equals 2. So we have 2, 0, and 4, 0. So those are the points. We can graph them easily. Take a look at the points of interest. So 0, 8, 2, 0, 3 minus 1 is the vertex, 4, 0. So we have those points. Now, it is interesting to see how we can get this point, an extra point, easily. By the concept of axis of symmetry, which is located at, with the vertex located at 3, -1. So if this distance is 3 and you go the same distance to the right, you get the same y coordinate. This must have the same y coordinate, and whatever this is multiplied by 2 in essence. So 3 go 3 more, and it gives you 6, 8. That's how we get that point. This is your axis of symmetry. X equals 3, and the graph looks like that. So domain for parabolas, whether they open up or down, makes no difference, is all real numbers from negative to positive infinity. The range depends on how they open. Since this opens up, it's from this point up, and this point has a y coordinate -1. So from -1 to infinity, -1 is included. That's the range. Decreasing this portion of the graph is decreasing, which means from -infinity to this point has the x coordinate 3. So from -infinity to 3 is decreasing. The rest of it from 3 to infinity is increasing. And make sure you put parentheses, of course, for infinity and -infinity, and the same thing for 3, as far as the increasing, decreasing is concerned. Example 4, given f of x equals minus x squared plus 8x minus 12, determine whether the graph opens up or down. Obviously, this means it opens down. Find the vertex. axis of symmetry, draw the graph, find the intervals of increasing, decreasing, the domain and range. We're going to repeat the question here. And so we are going to go with, again, the easy way out, x equals minus b over 2a. I hope you realize this is b, so minus 8 over 2 times negative 1. And we get 4, so let me, this negative sign should be here, everybody. All right. Now, all we have to do, the easy way out, plug in this number, which is 4, into the original function and evaluate it. So we are going to plug it into this function and evaluate it. So minus 4 squared is 16, so minus 16. 8 times 4 is 32. And then minus 12, they add up to 4. And so the vertex is located at 4, comma 4. A is negative 1, it opens down, and x equals 4 represents the axis for short or axis of symmetry. A quick recap. So 4 and 4, that's the vertex. Therefore, the axis has the equation x equals 4. A is negative 1, it opens down. Let's find the intercepts. Of course, 0, negative 12 is the y-intercept. The x-intercept, you set this equal to 0 and solve. To set this equal to 0, in order to factor it easily, we multiply both sides by a negative sign. This becomes x squared minus 8x plus 12, and now you want two numbers. The product is 12 and the sum is negative 8. You get minus 6 and minus 2. So this says x equals 6, this says x equals 2. And what it means, it's important to write them as pairs. This is 6 comma 0, this is 2 comma 0. So let's write the points. So we have the y-intercept at 0, negative 12. We have two x-intercepts, 2, 0, 6, 0, so 2, 0, 6, 0. And we have the vertex as at 4, 4. I'm going to discuss this last point in a moment. And so let's plot those pairs. Now, again, the axis of symmetry class, x equals 4. So if this one is located at 0, negative 12, and this distance is 4, the distance from the point to the axis of symmetry. So if we go the same distance 4, it gives us another point here. When we go the same distance 4, that ends up being 8. So 8 minus 12, just in case. All right. What about the domain? Domain is the same, all real numbers. What about the range? The range from negative infinity all the way to the y-coordinate of this point, which is 4, from negative infinity to 4. Now, the function is decreasing here. Which is from 4 to infinity. It's increasing over here, negative infinity to 4. Find a quadratic function given its vertex and 1 point. Determine the quadratic function whose vertex is 1 comma negative 5 and whose y-intercept is negative 3. So we are going to use this formula. A times x minus h, which is 1 quantity squared, plus k, which is minus 5. So plus minus 5, or simply minus 5. All right, so it's pretty straightforward, everybody. So what do we do next? Simple. We have a pair. Y-intercept is negative 3. That means the coordinates are 0, negative 3. So if you replace the x with 0, y, or f of x, becomes negative 3. So first, let me, okay, 0, negative 3. Okay, so replace the x with 0, y with negative 3. Now this one is negative 1, quantity squared is positive 1. So this thing becomes positive 1. Minus 3 is a minus 5. You move the negative, you make it positive on the other side. A becomes 2. And here's your function f of x equals 2 times x minus 1 quantity squared. You could expand this and write it as x squared minus 2x plus 1. If you distribute the 2, you get 2x squared minus 4x plus 2 plus 2, and minus 5 gives you negative 3. And the graph looks like that. We have seen how to graph parabolas. You can go through the process step by step if you like. All right, we're going to solve maximum and minimum problems. Note, a parabola that opens up has a minimum value at its vertex, and a parabola that opens down has a maximum value at its vertex. Find the extrema for the function f of x equals minus x squared plus 4x plus 5. So obviously, this opens down because a is negative 1. So if it opens down, it has a maximum. A is negative 1. Opens down, we have a maximum. Where does it occur? At x equals minus b over 2a. So x equals minus b, we replace it with 4, 2 times a, we replace it with negative 1. So minus 4 over minus 2 is positive 2. So what is the location at x equals 2? What is the maximum value is the y coordinate. And again, an easy way, plug in and evaluate it. So let's evaluate f of 2, which makes it minus 2 squared plus 4 times 2 plus 5. So this is 4. With the negative becomes minus 4 plus 8 plus 5. And the answer is 9. Maximum is equal to 9 at 2 comma 9. So very straightforward, I hope, everybody. There's really not much to there. Find the minimum product of two numbers that differ by 10. What are the numbers? First, we have to define our variables. Let's say they are x and y. We want to minimize the product which is equal to x times y, given that they differ by 10, given that x minus y is 10. You could write y minus x is 10. It doesn't matter. It's just that you're changing the two variables. If you write them in that fashion, there is nothing wrong with that. So the given information, let's quickly recap. First, we have to define our variables, x and y. Then, what is the objective? Minimize the product, which is x times y. And what is given? X minus y equals 10. And now, in order to minimize this, we are going to solve either for y or x. Normally, we'll solve for y. So y becomes, if you move the x to the other side, 10 minus x, and then multiply it by negative, becomes x minus 10, or move it in this fashion if it makes it easier. So move this one this way, this one this way, and y is x minus 10. You are going to replace the y here with x minus 10. The product of x and y becomes the product of x and x minus 10. And what we have done now, we have made it a function of one variable. So we're going to call it p of x equals x squared minus 10x. Now, what do we know about the shape, if you will? Okay. What we know is that we are dealing with a parabola that a equals 1 opens up, and the minimum occurs at its vertex. So graph of p of x equals x squared minus 10x is a parabola that opens up. The minimum occurs at its vertex. So let's find the vertex. X equals minus b over 2a. So minus negative 10 over 2 times 1, a is 1, and that gives us positive 5. So when x is 5, we achieve the answer. And what is y? You can go to this one or to this one and say y is x minus 10. So 5 minus 10, which makes it negative 5. So if one of them is 5, the other one is negative 5, their product is negative 25. So the two numbers that differ by 10 and their product is minimum would be, one of them is 5, one of them is negative 5. Find the maximum product of two numbers that add to 30. What are the numbers? Again, we have to define the variables x and y. Let the numbers be x and y. Their product is x times y. They add up to 30. X plus y equals 30. So we want to maximize everybody the product x times y, given that they add up to 30. All right. So we do the same thing. We're going to solve for y, which means we are going to move the x, and y becomes 30 minus x. Now we want x times y. So the product is x times 30 minus x, which makes it 30x minus x squared. We put it in descending order, becomes minus x squared plus 30x. Now what are we dealing with? Graph of a p of x equals minus x squared plus 30x is a parabola that opens down. The maximum occurs at its vertex. Because a is negative 1, it opens down, everybody. And the maximum occurs at x equals minus b over 2a, x equals minus b over 2a. So minus b is 30, 2 times a is negative 1. So minus 30 divided by minus 2 is positive 15. So it happens when x is 15. So if you put it back into this, x is 15, so is y. So x is 15, y is 15. Their product is 225. 225, everybody. So again, pretty straightforward. Everybody's okay with that. Find the quadratic function whose vertex is at 2, 5 and passes through the pair 3, 2. So we're going to go with the vertex format. F of x equals a times x minus h quantity squared plus k. We're going to replace the h with 2. So a times x minus 2 squared plus, we're going to replace the k with 5. Everything is there except a, and now we're going to use the pair, meaning we're going to replace the x with 3 and f of x or y with 2. So when we do that, 3 minus 2 is 1. When you square it, you get still 1. So you get a plus 5 equals 2. Subtract the 5, a becomes negative 3. And now this formula, replace the a, you get f of x equals minus 3x minus 2 quantity squared times x minus 2 quantity squared plus 5. Example 10, determine the value of maximum or minimum without graphing. In part A, f of x is 3x squared minus 24x plus 53. Obviously, a is 3. This opens up. So we have a minimum. Let's find x equals minus b over 2a, which means this is b minus 24. So minus negative 24 in the numerator, 2 times 3 in the denominator, and 2 times 3 is 6. This is negative and negative positive. 24 divided by 6 is 4. So the minimum occurs when x is 4. Let's plug it into this, and we get 3 times 4 squared minus 24 times 4 plus 53, and it ends up being 5. I leave it for you to simplify. It's easy to see, class. This is 16 or the 8 minus 96 plus 53. So we end up with 5. Minimum is equal to 5. Part B, f of x equals minus 2x squared minus 12x minus 24. Clearly, a is negative. This opens down, so the maximum occurs at its vertex, x equals minus b over 2a. Okay, the order wasn't good, so let's take it from the top. X equals minus b over 2a, so minus negative 12 over 2 times negative 2. Now, this is minus 4, negative and negative, positive 12 over minus 4 makes it negative 3. We put in negative 3 into the original function f of x. We get minus 2 times negative 3 squared, minus 12 times negative 3, minus 24. This is positive 9 with negative 2 becomes minus 18. Minus 12 minus 3 becomes positive 36 minus 24, and it adds up to negative 6, everybody. So I hope it's clear to everybody as to what's going on. The animation had a little bit of a problem, but the concept is understood. So let's move on. Without graphing, look at the vertex and axis of symmetry of the parabola defined by f of x equals 2x squared minus 3x plus 2. Does it open up or down? Well, let's go through that. Number one, x equals minus b over 2a. I'm going to use that formula. So this is a, this is b, this is c. Maybe I write that quickly so it becomes clear to everybody that a is 2, b is negative 3, c is positive 2. So minus negative 3 over 2 times 2. This is positive 3 over 4. Now you want to find the vertex, plug it in there and evaluate it. So 2 times 3/4 squared minus 3 times 3/4 plus 2. 2 times 3/4 squared minus 3 times 3/4 plus 2. Now, this is 9 over 16. When you multiply it by 2, you get 9 over 8 minus 9 over 4 plus 2. The common denominator is 8. And this is 9 over 8. This is minus 18 over 8. This is 16 over 8. They add up to 7/8. And therefore, the location of a vertex has x coordinate 3/4, y coordinate 7/8. Does it open up or down? A is a 2. It opens up. Axis of symmetry, x equals 3/4. So axis of symmetry, x equals 3/4. You don't have to do anything, just write this, x equals that. It's an equation. A equals 2, it opens up. A is 2, larger than 0. The parabola opens up. Use the information from the previous example and location of the intercepts to graph. Now we're going to continue in essence and graph the function. It is somewhat done, or to a certain degree is done. Okay, so it's really not too big of a deal. We have the vertex, we have the axis of symmetry, and we know it opens up. So we locate the axis of symmetry as well as the vertex. And as it was mentioned, a equals 2, therefore it opens up. We have all this information from the previous page. Now, f of 0 equals 2, clearly we can see the y-intercept at 0, 2. And so if we use the axis of symmetry, we know this distance is 3/4. So this distance is 3/4. So if we go the same distance, 3/4 6/4 or 3/2, we should have the same y coordinate. That's why. So I hope everybody's clear. And we know it opens up. Therefore, here's the graph. There is no x-intercept. Because it opens up. I leave it for you to calculate b squared minus 4ac. Let's show you. So minus 3 squared minus 4 times 2 times 2. Convince yourself this is negative, and that's why we don't have any x-intercepts. What about the domain and range? Increasing, decreasing? The domain remains the same, all real numbers. You're dealing with a parabola, opening up or down makes no difference. The domain is all real numbers from negative to positive infinity. What about the range? Because it opens up from the y coordinate of the vertex, which is 7/8, goes to infinity. So 7/8 to infinity. Where is this increasing? Where is this decreasing? This function is increasing on the blue side, this side, from 3/4 to infinity, the x coordinate of the vertex to infinity. And the red side is decreasing from negative infinity to the x coordinate of the vertex. So we have the graph, domain, range, vertex, increasing, decreasing, axis of symmetry, you name it. Graph f of x equals 2x squared plus 4x minus 1. Determine whether the graph opens up or down. Find the intercepts, vertex, and axis of symmetry. Clearly, A is true, positive, it opens up. The vertex, we're going to go with the easy way out. X is minus b over 2a. And let me write this. A is 2, b is 4, c is negative 1. So minus 4 over 2 times 2 results in negative 1. So in order to find the y coordinate, remember, if we put this in its vertex format, is a times x minus h quantity squared plus k. That's why we might say k is f of negative 1. So plug in negative 1 into the function. 2 times negative 1 squared plus 4 times negative 1 minus 1. This is positive 1 times 2 is 2 minus 4 minus 1. So 2 minus 4, minus 1 makes it negative 3. So the vertex is located at negative 1, negative 3. So we locate that negative 1, negative 3. And bear in mind, we know it opens up. And by the way, this would be the axis of symmetry, x equals negative 1. Axis of symmetry, x equals 1. So when you find the vertex, you find a lot of information. Right here, the constant is your y-intercept. In other words, if you replace the x with 0, you get 0 minus 1. So that's your y-intercept. And since this distance is 1, if you go 1 to the left, that gives you another point with the same y coordinate, if we were to find that. So also minus 2, minus 1 is there again. The reason is very simple. This distance is what? 1. So you go the same distance away, and that's by symmetry. All right. So here's the graph. And that does the job. If we want to find the x-intercepts, just to give you an idea, you have to use the quadratic formula here, and that's fine. So you set 2x squared plus 4x minus 1 equal to 0, and you get with minus b. I've shown you the formula before. So minus negative 4 plus minus the square root of b squared minus 4ac over 2a. Let me write that again. Somewhere here, x equals minus b plus minus the square root of b squared minus 4ac divided by 2a. And so you simplify that. This is 16, and this is plus 8, and you get 24. 24 is 4 times 6, so it comes out as 2 square root of 6. You factor the 2 out from the numerator, you get 2 times minus 2 plus minus the square root of 6. 2 and 4 cancel each other. 2 goes away, and the 4 in the denominator. And just 2. Now, you have to use a calculator for the sake of, finding the value. So minus 2 minus square root of 6 divided by 2, and minus 2 plus square root of 6 divided by 2 with an approximation using a calculator, we get 0.220, which is here, and negative 2.220, which is here. A domain, as always, are real numbers. Range from the vertex, the y-coordinate of the vertex, which is negative 3 to infinity. This function is decreasing the red portion from negative infinity to negative 1, and increasing the blue portion from negative 1 to infinity. So decreasing the red portion, negative infinity to negative 1, increasing the blue portion from negative 1 to infinity. Find the quadratic function given its vertex and 1 point. Determine the quadratic function whose vertex is located at negative 2, 3, and whose y-intercept is 1. And we're going to go with this format and replace the h with negative 2. It makes it, so let's just write this. With negative 2 makes this plus 2. And this is plus k, which makes it plus 3. And now the y-intercept is located at 1. The y-intercept means 0, 1, 0, 1. That means replace the x with 0 and f of x or y with 1. That's the meaning of it. 1 is equal to this. And of course, 0 and 2 is 2. 2 squared is 4, so this is 4a. So if you move this you get negative 2 divided by 4. You get negative 1/2. A is negative 1/2. Replace this. And f of x or y becomes negative 1/2 x plus 2 quantity squared plus 3. And you can use the information you have, plus finding intercepts, if you will, and graph the function, which looks like that.